the indices in there scale with the Bernstein polynomial. So in the words of Winnie the Pooh, I mean, as Eeyore once said, you know, if anyone was thinking about applauding, now would be the time to do it. I don't expect you to do that here. But that's the key thing. These have not been written down before, but nevertheless, these are now basis functions. This was the problem. You might wonder what's the problem. The problem was figuring out what to choose for the additional functions you get. You need to augment the space when you take the gradients of the H1s. These are the functions. And they couldn't really be any simpler. So these are functions that have got certain properties. They belong to Rabiot-Thomas. They have vanishing normal components on the boundary, and then you have this technical result that allows you to prove linear independence. So basically what that means is, if you take the dimension of the space, take away the functions you've got now, you end up with this magic number. That magic number may be familiar with it. I like to say the average Rhode Island, even the average Rhode Island resident would recognize it. So that's the dimension of that thing. I apologize for this juvenile behavior, but you know, I used to use Prosper for generating slides, and doing anything in Prosper is a nightmare. Then I started using this Open Office thing, and I found it difficult not to do this kind of juvenile thing here, so sorry for that. But that's the dimension of that space. Now the suggestion there is that the dimension of the polynomials of degree n plus 1, we've already got a basis for this. This is the H1 space. Is that. That's the number of functions that are missing. None of the functions we've got are in the image of the curls of these things. The Durand part of the Durand diagram tells me if I take the curl of H1, I get something in Hdiv. So what I would expect is Rabiot-Thomas should be these magic functions, these generalized Whitney functions, plus the curls of the basis for H1. So it's saying you take the basis that I've just talked about before,